my name's Olivia, and welcome to
Some Yum.
Glad you're watching today's Unit 6, Episode 1, Find the area between two curves.
Welcome! In order to make this delicious derivative cake, we need the finest ingredients from all across the world. We have 2 calculators from Einstein himself, pencils from the Amazon forest, and a ruler that Miss Ward used herself. We're going to put all those ingredients and let them sit and settle for a second. And now we're going to put in our other ingredients. We have our blood from all the times that you get paper cuts and everything else, so great. And then we have our sweat from like when you're taking tests and like tears when you get your awful test scores back. And then we have some salt that you're going to put a little in there and throw a little over your left shoulder for good luck.
Hi guys! While we're waiting for those cakes to bake, who wants to help me find the area of this delicious cupcake I'm gonna eat?
Okay, so to find the area between 2 curves, first you find the bounds of the area, so A to B, and then you do top minus bottom or right minus left, dx, which will give you the area. So in this case, we have a cupcake which is 2 inches long, so you do 0 to 2 of the top curve, the frosting curve, f of x, minus the bottom of the cupcake, g of x, and it will give you the area of the cupcake.
After those long 2 seconds of baking at 750 degrees, our calculus cakes are done, and oh my gosh, it just smells delicious. Ooh! Look at these magnificent beauties! Now that the cakes are ready, we're ready to put the curves on. But I have a question for you. What happens when your top curve becomes your bottom curve and then becomes your top curve again?
Thanks, Liv. Good question. So when the curves are switching from bottom to top, you're going to split the integral. So from 0 to 1, we have g of x minus f of x, because this is the top minus the bottom. You're going to add it to the integral from 1 to 2 of f of x minus g of x plus the integral from 2 to 3 of g of x minus f of x, and that's going to give you your area.
I don't know about you, but I'm feeling too much calculus. Now time for some commercial breaks.
Why don't they serve alcohol at calculus parties? Want to hear the punchline? Because you can't drink and derive. I'm serious. Drinking and deriving is the #1 cause of death on test days, so don't do it.
I hope you learned some important life lessons from Commercial Break with Esri today. Now let's get back to the calculus with Olivia.
Golly gee, oh my! But Esri, this one's a tough one. How would you find the area between these 2 curves if it's revolving around the x-axis?
Okay, so when you're finding the volume of the 2 curves revolving around the x-axis, you're going to put pi in front and then your bounds, so from 0 to 1 of top curve minus bottom curve squared, and f of x minus g of x is also referred to little r. In the picture you can see that Owen's hand is reaching for the donut, and the curve closest to his hand is little r, and the curve farthest away from his hand is acting as big R. Okay, so like I said before, this is little r and this is going to be big R, so you're going to do volume equals pi integral from a to b of big R squared minus little r squared dx, where r is the inner curve minus the axis of revolution, and little r is the outer curve minus the axis of revolution.
Thanks for watching today's episode. Before we go, let's review our formulas.
To find the area between 2 curves, do the integral from a to b and top minus bottom curve or right minus left.
For your disk formula, you're going to do pi times your integral from a to b and then times by r squared.
And for the volume of a washer, you're going to do pi times the integral from a to b with big R squared minus little r squared.
Well, we hope you learned something, so thanks for watching Unit 6, Episode 1 of Some Yum. We out.
Why was the parent function upset with its child? It was stretched to its limits.
That's right!
Oh, false calculus.